Hello everyone. In this video we are going to see the operation of common emitter and then how it gets amplified, and then we will see how the biasing is used, and then we will see the frequency characteristics for the common emitter amplifier. So basically common emitter amplifier. So in BJT we have three terminals called emitter, base and collector. So here we have three different configurations: common base, common emitter and common collector. Where common base, which we can use to amplify the voltage, and where in the common emitter the current will be gets amplified because IC is equal to beta into IE. And then here, what is the need for biasing? So biasing is nothing but when the external voltage is applied, the operating point should be in the active region. So because of the external applied voltage, the Q point or operating point might get shifted towards the cutoff or saturation region. So because of biasing, always the Q point will be maintained in the active region, so there will not be any clipped off output in the output side. So here in biasing can be done by means of three ways: either fixed bias, an emitter follower, and or voltage divider bias. So here in this one we have followed an voltage divider bias. So here the input side, the resistance has been divided by means of R3 and R4, and then we have an collector resistance and emitter resistance. So these are the coupling capacitance. So here we have given an input something called and 20 millivolts, and then the frequency I have given 1000 hertz. So now let us see how it gets amplified. So go to simulate. In edit simulation command, you please give 100 milliseconds. So here in sine wave I have used DC offset is 20 and AC amplitude is 20 millivolts, and frequency 1000 hertz, and AC amplitude I have chosen 1. Click run and check for the input and click the output. So here we can observe the input is around 20 millivolts, but whereas in the output we have amplified to the maximum value of 5 volts. So here we can observe that in common emitter amplifier the output is out of phase. There is a 180-degree phase shift. You can see here the input is like this. In the output you can observe that there is a phase shift between the input side and output side. So this is the transient characteristics. And then to check the frequency spectrum for the common emitter amplifier, then go to simulate, edit simulation command, go to AS analysis, please choose decade, and then the number of points per decade you please choose 10, and start frequency is 10 hertz and stop frequency is 100 megahertz. So give MEG and click OK. Then please give run. So here always the output voltage gain is nothing but output by input. So here the output is V of V out. Here in expression you can find V of V out divided by input node. Input node is N003. So we can observe that V out by V in. So this is the corresponding voltage gain. So here we can see the right side is nothing but your plot phase. You can delete that, and here we can observe the corresponding frequency, a spectrum for the common emitter amplifier. So always to find the bandwidth we should find the lower cutoff frequency and upper cutoff frequency. So to select that, to find that one, you choose the cursor, and then here we can observe that the magnitude is around, the maximum is 50 dB. The maximum is 50 dB. So we should take 3 dB from the maximum. So decrease to the 3 dB. So the lower cutoff frequency is 115.913 megahertz, and then upper cutoff frequency is, keep on reducing, we can find 3.9 megahertz. So to find the bandwidth is nothing but your upper cutoff frequency minus lower cutoff frequency. Then we can find the corresponding bandwidth for the common emitter amplifier. So this is how we can use a common emitter configuration for amplification purpose, and this is how we can find the frequency spectrum for an common emitter amplifier. Thank you for watching.